Hello guys, this is Arvind Kalia, and today I'm here to give you a webinar on the topic definite integration. As such, I have done MSc in mathematics from IIT Delhi, and so far it's been about 10 to 11 years that I am into IIT coaching. Today, as I'm going to give you a webinar on this definite integration, so let me just tell you a brief about this topic just before starting it. Certainly, I'm assuming that you have at least a brief idea of this topic. Right now, it's about like August end. So all of you either must have finished this chapter or you must be going through this chapter right now. Okay, if you have not even started this chapter so far, at least you must have done indefinite integration and you must have little idea of definite. Only then this webinar will make sense to you perhaps. Okay, now definite integration majorly consists of few properties of definite integration basically. This chapter majorly is all about properties. There are about 7 to 8 properties of definite integral which we study in this chapter. So today's webinar is primarily about one property which I preferably call King's rule. Okay, certainly not a standard term. I just refer to it as a King's rule because it helps us a lot in many questions. Okay, so it is there to assist me in almost like more than 50% of questions. So that is why it has some importance. So that is why I call it King's rule, and that is why I chose this property for today's session. Those who have done this chapter, they must be relating with the name King's rule because they must be knowing the importance of this rule. Guys, this is the basic property of definite integral that 0 to a fx dx is same as 0 to a f of a minus x dx. Right now, I'm not into the proof, but still to give a brief idea, just substitute a minus x equal to t in this integral and you will observe that this will become equal to this. The integral will become equal to left hand side. So that is a brief of proof. Now, guys, as such, this property has a lot of application. Today I'll be discussing majorly 2 applications of this property. Quite important application of this rule in particular is removing unnecessary, or better to say unwanted x from integral. Say there is some integral which is like you want to integrate something from 0 to a, and that integrand is having some term of x which you just wish that perhaps it will be better if this term is not there. So that is where this property will immediately come into role and it will help you to remove that x. Let me just clarify that statement by an example. Just look at this question. I want to integrate x sin x upon 1 plus cos square x. Just imagine, had this x not been here, question would be very simple. Just put cos x equal to t and you have your answer. But right now we have x here. So that is the meaning of unwanted x. We don't want this x to be here. Now this property comes into play. Look, just apply this property. Applying King's rule. Of course, do not use that term in your boards, okay? Applying King's rule. This will fetch you 0 marks because they don't know what is King's rule. It is just a term I am using. Applying King's rule, we get I is equal to f of pi minus x. That is, replace x by pi minus x. Like that. So if you see, this term simplifies to pi minus x sin x upon 1 plus cos square x. Let me call this as 1 and this as 2. This is I, and this is again I, but after applying property. Whenever you want to remove x from the integral, we apply King's rule and then we add both I. This step is very important. Adding 1 and 2. Students generally apply this property but forget to add. Guys, this is the addition part which will cancel this x. Now if you see, on left hand side we get 2i and on right hand side, denominator of both is same, so we take it as LCM. It is x sin x plus pi minus x sin x. So don't you think x sin x is getting cancelled? So I comes out to be half of 0 to pi. X sin x gets cancelled and we are left with pi sin x. And now my job is much simpler. All I have to do is put cos x equal to t and immediately realizing that this will become dt. Yes? So putting cos x equal to t, question is done. Certainly, when we substitute, my limits also change. When x is 0, cos x will be 1. And when x is pi, cos x will be minus 1. So my integral now becomes pi by 2, 1 to minus 1, dt with negative sign upon 1 plus t square. And now I suppose you can easily do it. Minus pi by 2 tan inverse t from minus 1 to 1. So that was one simple question just to explain how this property removes unwanted x. So whenever you see some integrand from 0 to a and you want some x term to be removed, that term is disturbing you. It might be x, it might be x squared, it might be x cubed, any power. Just apply this property, add. Do not forget addition. Add both I and this x will cancel out. Okay. And moment it goes out, question will be very simple. Let us see more example and try to support this argument. See, this is one of theoretical questions. By the way, it is IIT 1982. Quite an old question. We want to prove 0 to pi x f of sine x dx. Here f is any function is equal to pi by 2 0 to pi f of sine x dx. Now, if you just relate these two terms, then you will see primarily it's x which is missing here. Now that gives me enough idea to use King's rule. I want to remove this x, that is my target. So I have clear approach in my mind. I'll start from left hand side. I'll apply King's rule. Try to see such an easy question, because why I'm saying easy, because approach is very obvious. Moment you know the application of King's rule, you know this question is purely like pure application of King's rule. You want to remove x, you know how to remove x. So applying King's rule, it is pi minus x f of sine of pi minus x. अरे ये तो हो गया मेरे ख्याल से, कुछ रहा ही नहीं. It's done. It's pi minus x f of sine x. And now what we are going to do? Yes, we are going to add these two statements. Never forget this addition step. So 2i will be equal to 0 to pi. I'm straight away writing, guys, x into f sine x will cancel out and you will be left with pi times f of sine x. And it's done. Such a simple question, and that too in IIT. IIT, man, such a simple question. How it can be? Maybe it is not simple for those who don't know that how do we deal with that x. But the moment you know how to deal with unwanted x or the x which you want to remove, this question is very simple. Too simple to be asked in IIT at least. So that is all you wanted to prove. Just have a look. Just go through the proof quickly. So we observed, we applied property, we did addition, and x goes out of picture. Okay, guys, let us take few more examples. Look at this question. Again, certainly this x is not appreciable here. All the terms other than x are trigonometric, which we know we can handle by some standard formats. But this x is somehow disturbing it. No issues. We know how to remove it. Just apply King's rule. You may try this question parallelly on your copy. I'll appreciate that if you do that right now. Apply King's rule. So you get I equal to 0 to pi by 2, pi by 2 minus x. Guys, let me straight away write the values. sine of pi by 2 minus x. Now that becomes cos x into cos of pi by 2 minus x. That becomes sine x. Divide by cos of pi by 2 minus x power 4. That is sine x power 4. And similarly, here we get cos power 4x. I hope you understand that. Here, when you put pi by 2 minus x, it becomes cos x. And here, when you put pi by 2 minus x, it becomes sine x. Similarly, in the denominator. Now, what should we do? Yes, addition. And that's all. So let us quickly add them to get 2i equal to 0 to pi by 2. Denominator is same. And in numerator, x into sine x cos x gets cancelled. And you are left with pi by 2 sine x cos x. So now at least x is gone. So your I is, let me take this pi by 2 outside, divided by 2, it becomes pi by 4. So we get this thing. Now it's pure trigonometric format, which by the grace of indefinite integral, we know how to tackle. Standard format, guys. Whenever net power of each term is even in trigonometric form, integrand is involving sine and cos, and net power of each term is even. Net power is 2 because it's like multiplication. Power 4, power 4. So whenever we have such format, we always prefer to divide by the power of cos x. So in numerator and denominator, divide by cos power 4. Now you must have remembered that is how we proceed when we have even powers, because that creates tan x here and secant square in the numerator. So when you divide this by cos power 4x, this will become tan. This will cancel out. Cos square is still left. It will become secant square. So you have tan x into secant square x dx. अब तो यार आता है, nothing is left. Clearly we will put tan x equal to t. So secant square x dx is dt. My new limits are 0 to infinite. So my I is pi by 4, 0 to infinite, t dt upon 1 plus t power 4. Majorly, something which I wanted to teach you in this question is done. My purpose of this question is done. We removed x, we brought it down to a better form. After that, I will really appreciate if you complete this question properly using the method of indefinite integral. Still, let me give you a hint. Many of you must have made out what to do now. Obviously, we will put t square equal to u. So this will become du, and this will become 1 plus u square. That is like integral of tan inverse u. Okay, so now you want to you have to solve it completely and get the answer. Again, If you look carefully, IIT 1985, primarily this question is checking two important points of your preparation. Number one, you must be knowing how to handle this X, which at least now you know. Maybe you might be knowing it beforehand also, but now I'm pretty sure you know how to handle this X. Second, it is not that you just apply property and you get the answer. No, you have to be a bit more patient and bit more fast at calculation. So moment you remove X, it became a standard form of indefinite, which you solved by the method of indefinite. Dividing by cos power 4, getting something good, then putting 10x equal to t, getting something even better, and then putting t square equal to u. So one is concept, how to remove x, one is solving part. You have to be good at solving part, otherwise this concept is of no use. And that will only come with practice, right? Okay, so please complete this question. I'm leaving it for you. If you want to note it down, please note it down. You may note down the question and then do it completely. Huh? Okay, so this is like the first use of King's rule. And I'm again mentioning x square, x cube, anything, it will work for all. Look at this question now. A similar question was asked in IIT, I forgot the year, a similar question, not exactly same, but similar. Before I do this question, I want to refer to one basic question. Please look here. Say you want to integrate this. A very basic question. Those who have done in definite integration, they must be realizing that it is a very basic question. Say we want to integrate this expression. This is a standard method. We apply King's rule. And something which we get is really nice. Cos x plus sin x. All the sine terms become cos and the cos term become sine. Now clearly we know we will add, because addition normally helps when we apply King's rule. Always keep that in mind. Maximum students apply King's rule and then they stuck. Whenever you apply King's rule, most of time you have to do the addition part. Addition will help you. Moment you add these two i's, try to see in denominator we have same expression, so that is your LCM, and in numerator it will become sin x plus cos x, which will finally cancel out, and you will get 2i equal to pi by 2 and I equal to pi by 4. Now, if this question is like basic for you, let me assume you have done that so far. If you haven't done that, at least now you have seen it. Then you might relate this expression with this expression. Little bit. I'm not saying too much. Little bit. Okay. If I have to give you one more example, say we want to integrate 0 to 9 Sorry. There is no need of that. Not at all. I'm pretty sure you have gotten what I wanted to convey. Now let me come to this example. One thing is for sure that I'm not liking this x here. Secluded. All other terms are in sign. ये अकेला ही बैठा है x. We don't want it. Okay. But one thing which I must observe before doing anything is x square, x square, x square. Guys, if you have done indefinite integration, then obvious first step that should come to mind is put x square equal to t, because its derivative is with dx. So that will become dt. So moment we put x square equal to t, that is 2x dx is dt. Certainly I'll be having new limits 0 to log of 6. My integral will become 0 to log of 6. Half comes out, sine of t dt upon sine t plus sine of log of 6 minus t. Now I will really appreciate if you take 10 to 15 seconds or even 30 seconds and without using pen and copy, observe that King's rule will actually simplify this expression a lot. You may have a reference of this example and then focus on this question. Take 30 seconds. Do not use pen copy. Just try to observe that if we apply King's rule, this will happen. If we add, because normally addition helps, then something good will come out, which we would appreciate. Try to see. Yes. अरे शाबाश, क्या बात है, very good. Certainly, moment we apply King's rule, my I will become 0 to log 6 sine of log 6 minus t upon sine of log 6 minus t plus, guys, try to observe, this term will become sine of log 6 minus log 6 minus t, which will be nothing but sine of t. So here we will have sine of t. Now obviously we will do the addition part, and this addition is going to do wonders for me. Half comes out. I'm just expecting that you can easily see that inside I'm going to get 1. Yes, they will cancel out, like here they cancelled out. So it will become 1 dt. So clearly my I is 1 by 4 log 6. Just have a look. क्या बात है, great. Now we have done a basic application of King's rule and we have totally digested it. Now let me give you the second approach we use with King's rule, or the second application of King's rule. So first is removing unwanted x from integral. And what is second approach, second application? Look at the question. By the way, this is also a previous year IIT question. Second application is whenever you have some integral which is like you are completely out of focus, that what should I do? It is not at all a good format, nor we have a good like x which we want to remove, anything. Well, kuch samajh hi nahi aa raha, you're not getting anything. So if there is some integral which you are like out of ideas that what should I do with it, but you see that limit is 0 to a types. Guys, you must give a try to King's rule. Let me tell you, it will simplify. You may try it with the questions. You just solve questions and say there is some integral which you are like unable to do anything with it. But one thing is good, that limit is 0 to a. Apply King's rule, it will be done. That is the second application of King's rule. If you are just out of ideas, but limit is 0 to a, apply King's rule, it will solve your question. Applying King's rule. What will you get? 0 to pi by 4 ln of 1 plus tan of pi by 4 minus x. Guys, I just expect you remember tan of a minus b at least. 1 minus tan x upon 1 plus tan x. So use this, just open up tan of pi by 4 minus x. Now taking LCM, you will get 1 plus tan x here. It goes up, tan cancels out, 2 here, like that. So this is something you have after King's rule. Sir, this is also not good, this is also bad. You are forgetting one thing. Whenever we apply King's rule, addition plays a significant role. Addition तो करके देखो. Moment we add them, what do you get? It is ln of 1 plus tan x plus ln of 2 upon tan x. Oh, sorry, 1 plus tan x. Now I can expect at least this much, that you know this property, that ln m plus ln n is ln mn. So 1 plus tan x will cancel out and you will be left with ln 2. By the way, if anybody is having confusion, let me tell you, ln stands for log to the base e. It's a short notation for that. We also call it ln or natural log. So guys, I suppose it's done. So this is ln 2 into pi by 4. Therefore, my I 2i is equal to this. So I will be pi by 8 ln 2. So the question which initially seems to be like, what should be done with this question? Okay, what should we be doing to simplify it? Moment you observe that limit is 0 to a, applying King's rule, adding them, it's done. And it was one of the previous year of IIT. Now, how can they complicate this question one step ahead? How? See, this was like still a direct question, I will say, because I too could see that it is 0 to a. King's rule is at my will. I will certainly try to use it. They can further complicate this question a bit like this. In this part, even if you apply King's rule, you will not get something really good. And otherwise, I'm not seeing anything really good to start with. But one thing which I can easily observe, 1 plus x square. Guys, this is the mantra of indefinite as such, that when you don't know how to integrate, but there is some expression which is having a standard substitution, like root of 1 minus x square, we put x equal to sine theta. A square plus x square, we put x equal to a tan theta. There are some standard substitution, if you remember, from indefinite. So if there is some integral which you don't know how to proceed with, but it has some expression which is having a standard substitution, start from there. So in this question, my first attempt will be trying the standard substitution. Put x equal to tan theta. So my dx becomes secant square theta d theta. Certainly new limits are 0 to pi by 4. So my integral becomes 0 to pi by 4 ln of 1 plus tan theta secant square theta d theta upon secant square theta, and try to realize it is the same question which we just did. So the examiner can add this one step to the previous question to make it a little bit more complicated. Just have a look. Great. Guys, before we do this last question, which is actually looking not so good, let me give you the brief of this course. Guys, this is a course for definite integral. It is like it will be consuming about 5 to 5.5 sessions, each session of 1 hour 45 minutes. And you can join these sessions with me on Vedantu. Exact costing of this chapter is near about 1500, but for next few hours, those who have attended this webinar, for them it is for rupees 999. Okay, so if you think that this webinar was of help to you, then believe me, this chapter at Vedantu, when you'll do from my side, will be really benefited for you. Okay, you will be benefited if you do this course here. I'll be picking up all the properties, all the standards, non-standards. I'll be telling how to study the typical property, what is the basic application of basic property, every property. So if you really want to learn this chapter, I'll be waiting for you on Vedantu. It is starting from 30th of this week, this month, 30th of August. So see you in the sessions. Now let us come back to this question. Guys, what is the first thought that comes to your mind when you see this question? Let me tell you, sir, we will leave it. That's the first thought, at least, which will come to the mind of a normal student if he sees this kind of question in the exam. Who will do it? Better leave it. But what interesting or what really good information is given in this question? Number one, sir, we don't know how to do it. Number two, limits are 0 to a times. What did I tell you just now? It is also an application of King's rule, that if there is an integral which is really bad, you are unable to think how to proceed, but the limits are from 0 to a. Just apply King's rule. So guys, moment you will apply King's rule, of course, in this question you have to do little of calculation part. Five plus 2 times 1 minus x minus 1 minus x whole square into 1 plus e raised to power 2 minus 4 times 1 minus x. This is something we'll get. Guys, I suppose you will be able to just simplify it. Just simplify it. You will get a quadratic and this expression which is containing e. And moment you will add these two i's, you will see that something really good comes into picture. Initially, it doesn't seem to be that something good will come into picture. But let me assure you, the moment you will add it, you will see something really good coming into picture. And that thing you will be easily integrating to get your answer. So with that exercise, I'm concluding this webinar. Okay, so this is one question which I'll suggest you to solve yourself, because let me assure you that if you just do this question completely and you get something good, you get your answer, it will generate enough confidence in you that if I can do such a bad looking integral with an ease, by ease I mean at least I know what is the standard approach, then I can do any question, at least of this property. So guys, like this property, there are about 6 to 7 other properties which we will be covering in detail in the complete course, which is of 5 to 5.5 sessions. each session of being 1 hour 45 minutes, starting from 30th of August. So see you in the sessions. Till then, God bless you. Enjoy. Take care. Okay, guys. Bye-bye. By the way, what's my name? Arvind Kalia. Bye-bye.